Assalamualaikum warahmatullahi wabarakatuh and good morning. Video lecture part 2. So this is the outline for our lecture today. Okay, sigma operator. Sigma operator is represented by this symbol. Okay, this one is sigma. And what does it mean? It shows that you have to add up a series of terms. Okay. To make it more simple to understand, so let us look at to this example. So a chemist is stocking the laboratory before starting an experiment and needs to order conical flask. So in this case, he makes 4 times ordering the conical flask. For the first part, requires 2 flasks, the second 15, and the third 4. And the final part require 3 flasks. So what is the overall number required? So if we look at to this question, you can total the number of conical flasks like this, 2 plus 15 plus 4 plus 3, and it will give you 24. But we can use a shorthand by using the sigma operator to represent the total number of conical flasks here. So it becomes sigma starting with I means initial is equal to first item plus second item plus third item and so forth. And you can also write like this, means the total number of conical flasks is represented by the sigma notation with the starting point I is equal to 1 until n. And the operator for this total number is bracket flask. I means shows the initial. In chemistry, normally we are using the sigma operator in thermochemistry. Okay, let's look at this exercise. Okay, consider the following reaction. Okay, so this is the reaction between carbon monoxide react with oxygen to produce a carbon dioxide. So in thermochemistry, you have to calculate what is the enthalpy for this reaction. So we know that the enthalpy is the difference of heat between the products and the reactants. So to calculate delta H reaction, so delta H here actually shows the enthalpy. So theta here shows the standard condition, means the normal atmosphere and normal temperature. So RSN referring to the reaction. So reaction means for the whole reaction here, what is the enthalpy? What is the difference of enthalpy between the products and the reactants? So you are given the enthalpy of formation. So F referring to the formation of the carbon monoxide is equal to negative 110.5 kilojoule per mole. And for the enthalpy of formation for oxygen is equal to 0. Why 0? Because this is the condition for oxygen which exists as 2 atoms. So anything that exists in the condition form, so it becomes 0. Okay, so the enthalpy of formation for carbon dioxide is negative 393.0 kilojoule per mole. So by using this enthalpy of formation, you have to find what is the enthalpy of reaction for this reaction, means the formation of carbon dioxide. So this is the formula to calculate the enthalpy of reaction. Okay, the sigma means the total sum of enthalpy of products minus the total sum of enthalpy of reactants. Remember, you can only use this formula when you know the enthalpy of formation for each reactants and products which exist in one reaction. Okay, if you do not know about the enthalpy of formation, so it become a little bit difficult. Okay, and then by using this formula, you just substitute the value given here into this formula and you can get or can calculate the enthalpy of reaction is equal to negative 565.0 kilojoule per mole. Okay, we go to the next question. So this question also involve the thermochemistry, but a little bit different because in this case you only know the mass of the sodium and what is the enthalpy of a reaction evolve during 0.56 gram of sodium react with excess fluorine. And you are asking to calculate what is the standard enthalpy of formation. So anything when you want to solve the problem, you have to look at to the condition whether it is the standard state condition or not. So if it is at the standard condition, so everything involved in the standard condition, and you will get the standard enthalpy also in the standard condition. Okay, so how to solve the problem? First, you have to find out what is the number of mole for 0.56 gram. So the number of moles, so you have to divide by RAM, relative atomic mass, for the sodium. So you know that is 23. So divide, you will get 0.024 mole. Then, by looking at the question, you have to know how to write the chemical equation. So the chemical equation here involve sodium in solid state, fluorine in the gas state, but in this case, you only use half mole of fluorine to form 1 mole of sodium fluoride. And you do not know what is the enthalpy of reaction from the question given here. Why? Because we know that only 1 mole of sodium will form 1 mole of sodium fluoride. So in the question here, you only use 0.024 mole of sodium to produce 13.8 gram, 13.8 kilojoule of heat. Means release 30.8 kilojoule of heat. Okay. Then you have to calculate what is the heat release if the sodium is 1 mole. Because you want to find 1 mole of sodium fluoride. From the chemical equation here, you know that 1 mole of sodium will produce 1 mole of sodium fluoride. So by using the number of mole here, you can calculate what will be the heat evolved if 1 mole of sodium used. Okay, so from this you will get 575 kilojoule. Okay. Then you can write the chemical equation like this. You know the enthalpy of reaction. So negative means show energy release or evolve. So by using the formula that we had learned before, the enthalpy of reaction is equal to the sum of enthalpy of formation products minus sum of enthalpy of reactants. Okay, you just substitute the value. Okay, for the reaction, we know it's negative 575. We want to get what is the enthalpy of formation for sodium fluoride. So we have to know what is the enthalpy of sodium and also the enthalpy of formation for the fluorine. Remember, you have to know what is the standard condition for certain products or reactant exist in the standard condition. So for the sodium, it exists as Na in the solid form. So this information should be is equal to 0. Same thing for the fluorine, it must exist as F2, means 2 atoms needed at a standard condition to form fluorine gas. So this will be 0 also. And 0, 0. So you will get that enthalpy of formation for the sodium fluoride is equal to the enthalpy of reaction. Means the value will be negative 575 kilojoule. Okay, next we look at to the delta notation. Delta notation is written like this, triangle. So if you look at to this symbol, it doesn't mean anything unless it accompanied with an argument. So that means, for example, this one shows the difference. Okay, subtract the initial value of the argument from its final value. So this will be the operator, and delta will be the operator, and x will be the argument. What should you do? Okay, so in this case, we can say that x final minus x initial will give delta x, the difference between final and initial. Remember this statement, delta x mean delta operates on x, not delta multiplied by x. Don't misconfuse on this. Okay, we still discuss about the thermochemistry topic. So this is a diagram to show how the difference of enthalpy be calculated. Okay, so in this case, we can see that the enthalpy of initial is higher than enthalpy of final. So the difference between this will give you the negative answer. So when we look at to the negative symbol, we know that the energy is released. So this process is called the exothermic process. In the other way around, where the enthalpy of initial is lower than enthalpy of final, so the answer of this difference will give you the positive, or we say the energy is absorbed. And this process is called the endothermic process. Okay, so this is the formula how to calculate the delta H. Okay, and delta here is an operator, while the H is a symbol for the enthalpy. So if you have the theta that I showed you before, it shows that the enthalpy is taken at the standard condition. If nothing, that means there is a specific condition where the enthalpy is measured. And the magnitude of delta H depends on the vertical separation. Okay, so from this, you can know whether it will show you negative or positive, or direction is energy release or the energy absorbed. Okay, for this example is related to the Gibbs free energy, delta G. And you want to calculate what is the difference of this free energy. Same thing, we use the delta. So in this case, we have delta G is equal to the G products minus G reactants, and substitute all the value given in the question, and you will get that it will shows you negative sign here, 4.09 kilojoule. Okay, the next example is about the electromotive force. Same thing, you are given the EMF increases from 1.4 volt to 1.55 volt during a process. So you have to calculate what is the value of delta EMF here. So same thing, by using the final minus the initial, so you will get like this as 0.15 volt. Okay, next we are looking to the unit. So when we say something is a number, we have to follow with the units. Okay, so the number only shows the magnitude, but the unit will show you the dimension. For example, if you look at to the 7 base physical quantities in this table, you can see what is the measure. For example, we are measuring the length, so the symbol is a small letter L. But what is the unit used? So according to SI unit, so the length are measured in meter, and the symbol for meter is M. For the mass, we use the kilogram. For the time, we use second. So this is the unit with the physical quantity. Okay, so but when you use the ratio for something with the number and the unit, it will give you no dimension. There is no unit. For example, when you make a relative density, means you divide density with density, so it will cancel off the unit, so there is no unit occurred at the last answer. Same thing when you make a relative molar mass or mole fraction, there is no unit. Okay, so this one you have to be more careful. Okay, unit obey the laws of ordinary algebra. Okay. Okay, this slide shows you how you can use the unit to solve any problem. Okay, so let's look at the question, what is the number of mole of benzene contains in 1 centimeter cube at 298 Kelvin? So you are given the volume and also the temperature. So how you can relate these two to calculate the number of mole? So the extra information given here is the density at the same temperature. Okay, so if you look at to this one, row here shows the symbol for density is about 879 kilogram per meter cube, and the molar mass for the benzene is equal to 0.078 kilogram per mole. So what should you do first? You have to convert the density. Okay, so when you use this formula, you can convert the density into kilogram per centimeter cube like this. Okay, because this one is given in kilogram per meter cube. So you have to make sure when you make a calculation, the unit must be standardized. Okay, so you change this one by divide into 100, so you will get like this. Then we know from this unit and value given here, 1 centimeter cube of benzene has the mass of this one 0.0008979 kilogram, which is equivalent to 0.0113 mole. Okay, how you get 0.0113 mole? Because you have to divide by the molar mass of the benzene in 1 mole. Okay, this slide shows the SI derived units. It means how you can get the unit for the force. Okay, for the force, you have to multiply mass with the acceleration, then you will get the unit for force is kilogram meter per second. Okay, or the other unit is called Newton and the symbol will be N. Same thing for the others. Okay, you can study it later on. Okay, for ideal gas equation, we know that PV is equal to nRT. So how to express the SI unit for PV? So PV is equal to Newton per meter times meter cube. So this is the force, and this is the pressure times the volume. So you will get Pascal meter cube as Pascal because of this. Also called joule. And for the nRT, if you substitute the unit, you can get mole for the N. R will be the unit joule per Kelvin per mole, and T is Kelvin. So at the last, same as a PV. So you can see that both give the same unit joule. Okay, for those who are going to study computational chemistry or the atomic spectroscopy, you are going to face these atomic units, okay? And you can see that a little bit different than usual. For example, in the mass, the atomic unit will be ME and the value will be like this. Okay, same thing for the others, okay? Okay, one example here, calculate the ionization energy of hydrogen atom in unit of eV. To three significant figure given that the binding energy like this, and 1 electrovolt here has the value of 1.6 times 10 to power of negative 19 joule. And to solve the problem, the ionization energy is equal to E is equal to this one given here, the energy times what is the value for 1 electrovolt. Okay, you just divide by 1 electron volt here is given in joule, so you will get 13.6 electron volts in the atomic unit. Okay, that's all. See you in part 3.